Surface Optics Corporation was founded in 1977 on optical properties measurements and signature analyses based on those measurements as shown at the bottom and middle left. We are the recognized leader in measurement of optical properties, from 200 nanometers to 200 microns. Our signature analysis capabilities include full first principles phenomenological modeling of scenes, targets, and sensors from ultraviolet to millimeter wave. In the early 1990s, we expanded our business to include coatings, both vacuum deposited and pigmented coatings. We have over 30 years history of coatings for spaceflight hardware, encompassing multiple applications and technologies. The bottom row shows the primary mirror of the Kepler Space Telescope after coating in one of our large vacuum chambers. Our pigmented paints are generally geared towards signature control. Our software tools define surface structure and coating and binder recipes for desired angular and spectral characteristics. At about the same time, we also expanded to manufacturing reflectometers and spectral imaging systems. Our reflectometers, an example of which is shown in the bottom row, include both laboratory systems and handheld systems. Our spectral imaging expertise encompasses multiple modalities, including our latest light shift technology, which captures all three dimensions of the spectral image cube, two spatial and one spectral, simultaneously and at video rates or beyond. Output from our real-time 2 to 5 micron hyperspectral imager is shown at the top left. In this figure, the system shows a car's hot exhaust CO2 red spike emission as a green plume. Our thrust is video rate generation and exploitation of spectral imagery to provide actionable information, not just data. Supporting our spectral imaging systems is over 30 years' experience in spectral image processor design, culminating in our current Midas Ultra processor, shown in the top middle, a nearly credit card-sized board capable of interfacing to almost any focal plane array and performing full calibration and data exploitation. Our other supporting capabilities include camera electronics design, optical design, and optomechanical design. We are experts in the characterization, control, and exploitation of surface optical properties, hence our name. Current proliferation of small UAVs, both commercial and military, represents a significant threat to naval and other DoD component assets, given their availability and low visibility at range. To better protect naval assets from these small UAVs, we are developing SUADs. The spectral imaging UAV detection sensor based on our light shift full motion video spectral imaging technology, operating in the shortwave infrared through long-wave infrared. This system provides day-night all-weather detection and tracking of small UAVs at long range, providing many minutes to identify and interdict a UAV threat. SUADS detects and tracks 2/3 meter-size UAVs. For example, an octocopter at ranges up to 10 kilometers. Probability of detection is 90% or better, with a false alarm rate under 10%. Currently fielded assets for air surveillance, such as L and S-band radars, exploit relatively large radar cross-sections to identify airborne threats while not alerting on birds or airborne debris. Small UAVs possess cross-sections similar to birds and fly at similar altitudes and speeds, making reliable radar detection nearly impossible. A high probability of detection generates a similarly high false alarm rate. All DoD branches are at risk from this threat, as are civilian targets. Hence, the military needs a system capable of reliably detecting and tracking these small UAV threats. SUADS meets this need. This system detects and tracks threats based on the inherent spectral signatures of their component materials. These material signatures are unique and readily differentiated from spectral signatures of backgrounds, birds, plastic bags, or other airborne debris. Exploiting these material-based spectral signatures allows reliable detection of small UAVs even when they occupy just a single pixel, or even less than a pixel. Operation in the thermal infrared allows day-night operation and makes SUADs immune to obscurants such as fog, smoke, and clouds. SUADs embodies our light shift spectral imaging technology, using a dual-band focal plane array for operation in the shortwave through long-wave infrared, producing 32 spectral bands at every pixel in the image at rates of 120 full cubes per second. SUADS uses our Midas Ultra processor to exploit the spectral signatures at each pixel to detect threats, specifically small UAVs. Midas Ultra can detect and track hundreds of UAVs simultaneously, including multiple different types. By exploiting spectral signatures, the system is immune to clutter, as demonstrated at right, which shows our existing shortwave infrared system placing a detection crosshair on a small quadcopter seen against a highly cluttered hillside. At range, this quadcopter occupies little more than a single pixel, yet the video from which this frame was taken demonstrates the efficacy of spectral signature-based detection and tracking. The inset figure shows a close-up of the quadcopter with a peach-colored overlay on the detected areas. Another key feature of SUADS is that it is completely passive with no electromagnetic emission which enemy countermeasures can attack. As shown in the previous slide, we have proven our light shift technology for long-range detection of small UAVs. Under the current Phase 2 SBIR, we have fully designed SUADS and have key components on order, including the dual-band focal plane array and all optics. The Midas Spectral Image Processor and dual-band FPA interface daughter card are in-house and have been tested using a similar focal plane array. We have also implemented the baseline UAV detection and tracking algorithms on Midas Ultra. Due to significant supply chain issues caused by the pandemic, we have had to extend the period of performance for this SBIR, but will complete SUADS and test it at the 2025 Coastal Trident event. SUADS represents a breakthrough in reliable long-range detection of small UAVs. By measuring spectral signatures of UAV components and performing material-based discrimination, SUADS detects 2/3 meter-size UAVs at 10 kilometers, with over 90% probability of detection and under 10% false alarm rate. By comparison, current radar systems ignore the small return associated with such UAVs because birds present similar returns. Optical systems also can't differentiate the birds and airborne debris from small UAVs because they appear the same at long range and against clutter. Our 32-band shortwave infrared through long-wave infrared system offers day-night operation and is immune to common atmospheric obscurants, such as fog, smoke, and clouds. Optical systems, conversely, are blind in adverse weather conditions and perform poorly under low-light conditions. Our 32-band light shift technology is band optimized to detect UAV's solid constituents, enabling collection, processing, and detection at 120 full frames per second. By contrast, band-rich scanned hyperspectral imaging systems oversample the available spectral content, producing no more usable information at the cost of scan times more than 100 times greater than SUADS. We have already proven the basic technology for reliable small UAV detection at range and against clutter in early fiscal year 16. We then developed the concept for the current SUADS system under N68335-22-C-0209 Phase 1. Under the current SBIR, we developed a detailed system design by mid-fiscal year 23, and will have the system assembled in early fiscal year 25. We will test that prototype system in the lab and demonstrate and test it at the upcoming Coastal Trident 2025 event, bringing it to TRL 6. Our final step prior to transition to the fleet is to adapt what we learned through testing and produce a production-ready prototype, which will then be tested in theater, bringing it to TRL 8 by the end of fiscal year 26. To facilitate this transition, we require a government sponsor and prime contractor. Beyond protection of DoD assets, SUADS is ideal for protecting non-military assets from the threat of weaponized commercially available small UAVs. This includes protection of mass gathering venues, such as sporting events, concerts, and conventions. Transportation hubs are also at risk, especially airports where small UAVs could either directly attack or simply interfere with airline operations. Detecting and tracking them before entering protected airspace is key to eliminating the threat. Attacks against government buildings and key industrial sites could also be mitigated using SUADs. Beyond the intended detection and tracking of small UAVs, SUAD's light shift technology for material-based discrimination is readily adaptable to other threat protection applications, such as remote detection of explosives and explosive precursors, detection of chemical and biological agents, drugs, and other threat materials. SUAD's technology can do more than detect threats. Appropriate modification enables medical diagnostics, agricultural monitoring, such as directed water and fertilizer application, online manufacturing control, and any other application that can benefit from remotely identifying an image material or state of that material. To facilitate transition, we seek a prime contractor to bring this system to the military market and potentially even the commercial market. To this end, we will license our SBIR-developed technology and provide support to transfer our intellectual property required to successfully produce SUADs and similar systems. We will develop new capabilities through ongoing research and development and transfer those capabilities as appropriate. Please visit us at Sea Airspace at the National Harbor on April 7th to the 9th. We welcome the opportunity to discuss SUADs and its capabilities, as well as discuss potential partnerships and transition avenues, and to demonstrate one of our light shift spectral imagers. For more information, please contact Mark Dombrowski, President and CTO, at markd@surfaceoptics.com. You can also leave a message via cell phone at 760-522-6674. Thank you for listening to our presentation.